Welcome to episode 6 of my Kawasaki S1 550 4-cylinder engine build, and in this episode I'm going to be showing you how I rebore the cylinders, fit oversized pistons, and then fit the barrels and heads to the engine. I took the cylinder heads and barrels to the vapor blasters a few weeks ago and they came back all shiny and clean, so now they're all ready for rebore. All 4 barrels are standard size but slightly worn, so I'll bore them out to plus 0.5 using my SPS mini bore cylinder boring machine. The boring machine comes with its own calibrated toolkit, and I'll also need an imperial micrometer for measuring the piston. I'll be using my SPS mini bore motorcycle cylinder boring machine. It's made in around 1958 and I've had it for over 25 years. It's absolutely amazing and just perfect for the job. I ordered a set of 3 pistons from Japan, OEM spec, and they've just arrived. I already have one in stock, so that makes the 4 I need. I'm really excited to see the new pistons, so I used my penknife to open the packet and get them out. I'm always a bit excited unboxing new pistons. I feel like they become the heart of the engine. I line the pistons up in a row and mark them from 1 to 4 with my marker pen. Then they'll line up with the marks stamped on the barrels, 1 to 4. The boring machine works in imperial sizes, so I have to measure the piston with my imperial micrometer to get its size in inches. And it measures 2.262 inches, so I write that down on my piece of paper. Then I add the 2007-inch bore clearance and add the 2 figures together to get the size I need to bore the cylinder to. The boring machine toolkit comes with a special gauge that is used to set the length of the cutter. So this is set to the size I need to do, 2.264 inches. The cutters come in various lengths and are also adjustable with a little plunger and an Allen screw. So you loosen the Allen screw and you can pull the plunger in or out to adjust its length. The length of the tool determines the diameter of the bore that's going to be machined, so this has to be set up in the setting gauge. The cutting tool slots into the setting gauge, then you loosely do up the screw, just very loosely, then you can adjust the size to the exact size that you want, in this case 2.264 inches, and then you tighten up the Allen screw with the Allen key, and that locks the plunger in place, determining the length of the cutting tool. This is a really critical stage, so I double check the size, double check that it's tight, and then double check it again just to make sure, because if I get this wrong, the cylinder bore will come out the wrong size, and that would be no good. I take the tool out of the setting device, put it back in again, and then check again, and it's perfect. I'm really pleased with that, so now we're set to bore the cylinder. So this tool is now set for piston number 1 for cylinder number 1. The first thing I have to do is unclamp the boring head and remove it from the table. With the clamp loosened, it pulls out from the rear, and then I can lift off the boring head. It is really heavy. I'll make a bit of room, then, using a bit of cloth, clean the top surface of the table so I can turn it upside down because the cylinder barrel mounts underneath for boring. The cylinder boring machine comes with several cast iron rings. These are sort of spacers that fit onto the table underneath, and then you put the barrel on that you're going to bore, and there's various sizes for various bore sizes, and you put one on top as well, just to prevent the boring machine from damaging the cylinder barrel. Then you do up the screws really tight, but they've got like a clutch in them, so you can't over tighten them, so you put a small screwdriver in and pull it around, and you can hear it go click like a torque wrench. With the 2 clamping screws tightened, I turn the table back over and engage its support leg, and you can see the barrel clamped underneath, ready for boring. I then replace the boring head and clamp it loosely in place with a clamp. The next thing I need to do is centralise the boring bar to the cylinder, so that when it rotates, the cut will be even. In the toolkit that goes with the boring machine, there are sets of dowels that you insert in these holes to centralise the cylinder depending on its size. They come in sets of 3. So for a 2.264 cylinder bore, I need set number 4. The pins are tapered on one end and radiused on the other end, and the taper end goes into the boring bar. With the 3 pins engaged in the boring bar is then lowered down by turning the handle on the side until it reaches a portion of the cylinder that has no ports, and then the central knob in the centre of the boring bar is rotated a little bit until the pins come out and touch the side of the cylinder. This centralises the boring bar. The clamp is then tightened. With the boring bar centralised and clamped firmly in place, the 3 pins are removed and returned to their place in the toolkit. With the boring machine set, it's now time to fit the cutting tool, but first I give it a quick clean with an airline to make sure there's no little bits of dust or grit on it which could affect the cut. I use this special Allen key that gives just the right amount of torque to tighten it up without over tightening, and then we're all ready to go. So I turn on the machine and set the cut going. It takes about 15 minutes. When you rebore a cylinder, you get a lot of fine cast iron dust, so I use an old garage vacuum cleaner. It's not a good idea to use one out of the house because it makes it black inside. With the cut finished, I turn the handle on the side to retract the boring bar, and then I can rock the unit back so I can see the bore underneath and try the piston, and it fits just perfect. I am really pleased. So now it's all ready for honing. I loosen the 2 clamps and withdraw the yoke and take out the cast iron ring, and then I can get the cylinder bore out. It looks really nice. I'm really pleased with the finish. It feels really smooth. I then repeat this process with the other 3 cylinders. With the 4 cylinders bored, it's time to do the honing, so I first grip the cylinder in my vise using my aluminium soft jaws. Then I insert an adjustable 4-stone hone into the cylinder bore until it's just tight, and I use my electric drill very slow, going in and out at the same time to give a nice cross-hatched finish. With the cylinder honing complete, the next thing I need to do is chamfer all the ports inside the barrel, because if you don't do this you can break the piston rings. To chamfer the ports, I use my Dremel with a fine stone. It's a bit similar to being a dentist really. You're just grinding around the edge, taking off a small amount to make a nice chamfer. You need quite a steady hand when you're using the Dremel on the cylinder ports. And also, you need to grip it quite tight. You don't want it to suddenly move where you don't want it to go. You have to follow the contour of the ports as evenly as you can to make a nice smooth chamfer. The last thing I do is remove the sharp edge from the top of the cylinder bore. This is not ideal if it's left on because it can cause pre-ignition. With all the ports chamfered, it's time to give them a good wash in hot soapy water with lots of bubbles. This removes all the grinding paste and dust from the abrasive process. I run some really hot water and add some washing up liquid. Well, quite a lot really. I want lots of bubbles. With the sink full, I lower the barrels in and give them a good swill around. Then I use an old toothbrush and an old washing up brush. Not a good idea to use the actual ones you're using, so these are old ones, and then go around all the ports and the bore to clean them out. It's quite nice doing the washing up, especially when you're looking out the window, and sometimes the robin comes up to have a look. He's so nice. The old toothbrush is perfect for getting up the transfer ports and up the inlet and exhaust port. You can give it a good old brush to get any bits out. With the 4 barrels thoroughly cleaned, it's time to rinse them off. So I drain the sink and run some fresh water. I rinse each barrel in turn, paying particular attention to the transfer ports inside to make sure they're clean, and then give it a good shake off. I then use an old towel to give them a quick bit of a dry up and put them on the windowsill. But they're not quite dry enough, so I take them outside to use my barbecue. This is just perfect for drying off cylinder barrels. I put the cylinder barrels in the barbecue, shut the lid, and about 5 minutes later, they are lovely and warm. I didn't need to leave them too long because I only wanted them warm, not really hot, so just right to get rid of the water moisture. Then they're all ready for assembly. I open the door and there's a really nice smell coming from the kitchen, so I go and have a look, and Tracy's making some more cupcakes. This time they're chocolate cupcakes with cherries and chocolate ganache topping. She's already added the butter and sugar, and now she's putting a few eggs in, and then she's going to put in some flour and whisk the whole lot up. She loves using the whisker. With the mixture whisked, she adds some cocoa powder, lots of it. That looks really nice. Then some hot water straight out of the kettle. Then, after another whisk, she adds some Morello cherries. They've been soaking in rum all night, and they smell amazing. After yet more whisking, it's ready to be put into the cupcake cases. This part of the process is critical. It's really important to get the right amount of mixture in every cupcake, otherwise there could be small ones, and you wouldn't want a small one. They're all ready now to go in the oven for about 20 minutes, and when they come out, they look absolutely amazing. So now we can make the chocolate ganache topping. This is a two-stage operation. We have some cream and sugar in one pan and some chocolate and rum in another pan, and when the cream and sugar's heated up, we pour it over the chocolate and rum, and the chocolate melts, and then Tracy uses a different whisker to whisk it all up. This is a bit splattery, and it goes everywhere. Even Charlie Weaver gets splattered. He's been tasting the rum all afternoon just to make sure it's okay. The chocolate ganache topping now has to rest for about 20 minutes to cool down before we can spoon it onto the cupcakes, and it flows lovely into the cases, filling the top of the cake so it's all smooth and shiny. To finish off, half a cherry is placed in the exact centre of each cake, and then they look amazing. But I'm under strict instructions not to eat one just yet, because they're still warm and all the chocolate will just run off, so I go back to the garage. Back in the garage, the first thing I'm going to do is start assembling the pistons, so I put a circlip in each piston. The piston rings go on next, so I first fit the bottom expander spring, followed by the bottom piston ring. Then I fit the top piston ring, making sure I line up the pegs. Ring groove pegs are fitted to two-stroke pistons. This prevents the piston rings from rotating. If they rotated in the engine whilst it was running, they would get caught in the transfer ports and snap. So next I fit the gudgeon pin, and then to repeat this for all 4 pistons. Before I can fit the pistons and barrels, I'll need the base gaskets and the little end bearings. I pick up the first little end bearing and apply some oil and push it into the connecting rod. It slides in nicely, and then the piston can be lowered down until the gudgeon pin lines up with the side of the bearing, and it can be gently pressed in against the circlip tight. With the gudgeon pin pressed home, the next thing I do is fit the retaining circlip with my pliers. It snaps into place nicely. The next thing I do is fit the cylinder base gasket by sliding it down the 4 studs until it hits the crankcases, making sure the hole is at the rear for the oil lubrication. I then put a drop of oil on the cylinder bore itself so that it slides down nicely over the piston. I first compress the rings with my finger and thumb, engaging it carefully and giving it a bit of a wiggle and a bit of a push, and eventually the barrel slides down nicely over the piston and hits the crankcases. Just perfect. I now repeat the process by first rotating the crankshaft to get the next connecting rod at top to the centre, then fit the little end bearing, followed by the piston. The second piston drops right into place and the gudgeon pin slides straight in nicely, so now I can fit the circlip. I then fit the base gasket, sliding it carefully down the studs, and get the piston rings lined with the pegs, ready to drop on the barrel. The barrel then slides down nicely over the piston, engaging with the 4 studs. I now repeat the process for the 2 outer cylinders. Well, that's the 3rd barrel fitted, one more to do. With the last circlip fitted, I can now fit the last barrel and slide it down onto the piston. This one was a little bit tricky, but it eventually went down. It's really important not to force it, as you can break the piston rings. So now, here's all the barrels on, and when I turn it with a spanner, the piston will go up and down in the 1, 4, 2, 3 sequence. Before I can fit the cylinder heads, I've got 2 jobs left to do. I've got to anneal the copper cylinder head gaskets and make some new sleeve nuts, because I've only got one. I heat the copper gaskets with my blowtorch until they glow red hot. Then, just let them cool in air, or you can quench them in water, you'll get the same effect. With the 4 copper cylinder head gaskets annealed, I allow them to cool down. While they're cooling, I can get on with making the new cylinder sleeve nuts. To make the new sleeve nuts, I use an M12 by 100mm long stainless steel bolt that I first grip in the vise and saw off the thread. The stainless steel bolts are quite hard going with a hacksaw, but you get there in the end. I cut the bolt about 1mm longer than I need so that I can put it in my lathe and face it off. With the bolt faced off the length, the next thing I need to do is centre drill the end. The centre drill forms a small chamfered hole right in the centre of the bar. This will prevent the next drill I'm going to use from wandering off centre. I use a 6.8mm diameter drill. This is the tapping size for M8. I grip an M8 tap in the tailstock chuck, then do a couple of turns by hand. This will make sure the thread is running true. I can then loosen the tailstock chuck, slide the tailstock back, remove the tap and the bolt from the main chuck, take it over to my vise and finish it off with a tap wrench. You have to be extra careful when tapping stainless steel. Make sure you go backwards and forwards to clear the thread as it's being cut and feel for it tightening up and use a good oil. But after a bit of time and patience, the thread is right down to the bottom and I can wind it out, and that's the first one made. To finish it off and make it look nicer, I'm going to put it back in the lathe and face off all the marks on the end of the bolt so it's a nice smooth shiny surface. Then it'll look really nice between the fins on the engine. Well, that's much nicer. I'm really pleased with that. So now, 15 more to do. With all the sleeve nuts machined, I can now start putting on the cylinder heads. So first, I put new stainless steel spring washers and flat washers over the sleeve nuts. With the 4 sleeve nuts fitted to a cylinder head, I offer up a gasket and it fits perfect. So now I can put the cylinder head onto the engine and do up the 4 first sleeve nuts. I spin the nuts down by hand initially and then go around with my ratchet wrench to tighten them. I can now repeat the process for the second cylinder head, fitting all the sleeve nuts and washers and the gasket, placing it onto the barrel and tightening the nuts. The engine's really starting to take shape now, and I'm really liking these squared off barrels from the S3 compared with the KH250 barrels that are rounded. It's got quite an aggressive look, and I think it's going to look really cool in the bike. With the 4th cylinder head fitted, I can now tighten up all the nuts and make sure they're all the same, and then I put a spanner on the end of the crankshaft and gently rotate the engine, and it turns really free. I'm really pleased with that. So now I can put my electric drill on it and give it a spin. I just run my finger down the plug holes to feel the compression, and it feels great. This engine is going to have oil injection for its lubrication system, so I fitted a pump off a H2B Kawasaki. This has 4 outlets, so I can use 1 for each cylinder. The oil delivery pipes run along the back of the engine and connect up to 4 banjo bolts. The oil then runs up into the inlet manifolds, down the inlet track into the engine to lubricate the pistons and the crankshaft. I've temporarily fitted the kickstart just so that I can kick the engine over to see what it feels like. This will be bent in the future when it's back in the bike to miss things like the exhaust and the footrest because the engine's slightly wider than standard. Well, the engine feels great on the kickstart, and here you can see the pistons going up and down through the inlet ports. I then fit the oil pump cover with its 3 screws. Well, that's the top end of the engine complete, and I'm really pleased how it's turned out, and those stainless steel head bolts will never go rusty. Thanks for watching. I hope you enjoyed the video, and the chocolate ganache cupcakes are really nice. I've had one already. I've got another one out in the garage to eat. Just perfect. Anyway, see you all soon in the next video.